So that is, you're going to need to get used to using multiples and submultiples and using powers of 10 in your calculations. In some cases you might move away from that, in some cases not. It just depends on what you're doing. Sometimes that can make it look more complex, more fiddly with writing your calculation down to put it in that power 10 form than it is to write it in the decimal form. So mix and match, but choose whichever's least likely to get you to make a mistake. How easy is it to miss one of them noughts off in that 35 gigahertz? If you write it as 35 times 10 to the 9, you're less likely to make that mistake. Alright? So, what we're going to start to look at now, and we may not get all through this set of notes this morning, we'll see, is basic algebra. Now, every single thing we do in maths this year and in a level 5 next year boils down to you having a command of algebra. Because when you do the calculus, you'll struggle if you can't deal with the algebra. Yeah, the complex numbers, algebra. Every topic involves algebra and manipulating equations, simplifying, factorizing, changing, and so on. Okay? So you need plenty of practice. What we do in this class here will not really be enough for you to get a really good grade in the exams unless you're already really good at maths. Practice, practice, practice. So we're going to look at expanding, factorizing, simplifying. It's the basic grammar of mathematics. Uses symbols to represent numbers, constants or variables. People who don't like maths get frightened of algebra because they've got letters in it, A, X, Y. All that is A is a number. It's just called A because we don't know what it is, or we want to change it for certain conditions. As in alpha, X. And some people get even more confused when you use Greek letters. But unfortunately, engineering uses Greek letters for a lot of quantities. Ohmic is a typical one for ohms. That's a unit. But there are a number of places where quantities are actually expressed or written as a Greek letter. Angles are a prime one for that. Okay. So we're going to look at some of these skills over the next week or two. So, if I have that diagram, I can write that the area of the small square on the left side is 2y. Yeah, and I can write that the area of this rectangle here is x times y. So I could write an expression for the whole thing as being 2y plus xy. Alternatively, I could write an expression this length as 2 plus x and this length as y. So alternatively, I could write that. Yep. Now, I'm going to start on the right hand side. If I multiply out those brackets, what do I get? What'd you say, Lewis? 2y plus xy. Oh. What's that? Expand the brackets. Yep. What could I do what's it called that I would do to that side to get it back to what we've got there? Y times 2 plus x. It's called factorize, yeah? We take common terms in all the expressions that are there. We put them outside a set of brackets. So y is in this expression, and it's also in this one. So we can put y outside some brackets, and then to get back, you've got to look at what would it, if the y is outside there, what have I got to put here to get back to 2y? I've got to put 2, and that's going to be a plus, and to get to xy, by multiplying by y, I must have to put x. That's called factorizing. And so there's, from the two different ways of looking at that diagram, we can see there's two different ways of expressing it algebraically. And we can change from one to the other through the processes of either expanding the brackets to go from this expression to that one, or factorizing that one to go to the one over this side. And either of those two, if we knew details of what either x or y were in terms of a number, we could find out what the other variable was. Yeah. And there'll be many times when you need to factorize or you need to expand brackets and things in this math module to do your analysis to get your answer that you're looking for. Okay? What expressions could I write for expressing the area of that rectangle? What is, if I was, I'm going to, in red, look at the areas of each of these sub-rectangles. That's one way to do it, isn't it? So that one would be x multiplied by x squared. Yeah? This one is going to be x times y. This one is xy, doesn't matter what order. Multiplication, doesn't matter what order you write it in. Division, it does. Yeah? But 2 times 10 is the same as 10 times 2. But 2 divided by 10 is not the same as 10 divided by 2. Alright? Same as addition. Doesn't matter about the order, but subtraction, it does. Okay? There's a fancy mathematical name for that I can't remember, and I'm not interested in. But remember it. And this one is y squared. Yeah. Also, we could write, what's the length of this side? And this side. So we can have two complete expressions for the area of that rectangle. Yeah. So what would the red one be? Yeah, we've got x squared, we've got xy and xy, so we can straight away say that's plus 2xy. Yeah, and then plus y squared. Yeah, and how could we write an expression for the blue one? The green, sorry. Okay, you can go brackets x plus y times brackets x plus y. Is there a more succinct way I could write that? Yeah, so we could write it as x plus y all squared. And there'll be times when you've got a term like that, two terms in there squared, and you need to expand that out. So you write it out like that and expand those brackets. Yep.
You assume that two rectangles, so technically that might not be correct. I mean, if it's a square,
It look like a square, but a square is a rectangle with side length and width equal, isn't it?
so
Still a rectangle.
Assume that you've got two x's and that are the same.
Yeah, oh yeah. If you've got a variable called x, then all the in that particular function, that x is always equal to what you set it to. So all the x's are the same value. Yeah. All right. So what could we do on that side? We could put x outside some brackets. How do we get back to x squared? That plus 2y. We'd have to add the y squared on its own because that's not multiplied by x. So we could write it like that. We could leave x squared and say plus y 2x plus y and what happens if we multiply out these brackets here? X times x is x squared, x plus xy plus xy plus y squared. Essentially we're back over there. So multiplying out brackets, factorizing. But you can't always factorize both the variables in an expression like that. Okay? Right. I'm gonna skip over that one for the time being. Expand those brackets and simplify. What do we need to do? Multiply them out, yeah. What I see a lot of students do, and if that helps them get used to it, I haven't got a problem with it, as they say, I've got to go that times that, I've got to go that times that, and I've got to go that times that, and that times that. And if it helps, write them all out without simplifying straight away. So we go a times a is a squared. A times 2b is 2ab. B times a, it is normal to write the letter variables in alphabetical order, but not absolutely necessary, and plus 2b squared. And then we've got two AB terms that we can join together to say the final thing is 3AB plus 2B squared. Right, so that last bit is called collecting like terms. So we multiply out brackets, and we select like terms. Everyone happy with that? Yeah? What about factorizing that one? Yeah, Q is in both terms, so we can put Q outside some brackets. And then what do we have to do to Q to get it to 2Q squared? We have to multiply it by 2Q. And what do we have to do to Q to get it to 8QN plus 8QN? 8N, sorry. Factorized. Yep, well spotted. You can take the 2 out, so you can have 2Q outside. What do I have to do to get 2Q to 2Q? I have to multiply it by 1. Yep. Oh, it's Q squared, isn't it? It's Q squared, isn't it? I've got to get it to 2Q squared. Yeah. And plus, what have I got to do to get 2Q to 8QN? Multiply by 4N. Alright. So, factorizing means taking the common terms outside brackets. Yeah. And what you do and which terms you take outside brackets or when you multiply out depend on what you're trying to do with that expression. And the hardest thing for students seems to be about algebra, even if they've got a command of being able to do them operations, is knowing what to do. But that's a whole nother story. And sometimes the problem involves you trying something to see whether it works, and if it doesn't work, trying a different way. Yep. But it's one thing having a command of the techniques, it's another thing knowing what to do in a particular situation. Yep. What about this one? Subtract 2x plus 3y minus 4z from x minus 2y plus 5z. What we're saying, and probably the easiest way to look at this, is to write it out like this. X minus 2y plus 5z, and then write the other expression in the same order underneath. 2x plus 3y minus 4z, and then we're going to subtract. And we do it column wise. Now we can say x minus 2x is minus x minus 2y minus 3y. Minus 2 and take away another 3. Minus 5y. 5z minus 2y, take away another 3y. What order? because you can only subtract like terms from each other. Yeah? So you need to get them in that line and that line in the same order. That's just how it's worded. That problem come out of the Bird book. Yeah. So he's worded it like that. Oh, what? Because it says subtract that from that. If it said subtract that from that, I would have written them the other way round. Remember, subtraction, the order is important. You're taking that away from that. If you're adding them up, you could put them in either order, it wouldn't matter. Yep. Remember, 2 minus 10 is not the same as 10 minus 2. Plus 5 minus minus 4. Nine plus 9z. Yeah, they do. What you should remember, right, is this sign is applicable to that number when you're thinking about what you're going to do. And if you get this, that was 5 minus 4, and those two negatives come to make a plus. Alright, and more people lose marks in this exam, probably lose more marks in this exam for getting problems with sign and numbers than anything else. Very easy to do, particularly when you're under pressure and in a hurry. Alright, so don't be frightened to use your calculator just to check.
Why did we read it as 5 minus 4?
Because we're extracting that expression from that one. So and we're doing it column wise. Okay. So that plus goes with that. So it's plus 5 minus that minus sign minus 4. All right. And you've got to be careful with that. All right. 2p divided by 8pq. What can we do? What would be a nicer way of writing it? Make it look easier. On top of each other, yeah. 2p divided by 8p. Very rarely is there a reason to use that notation in engineering mathematics at this level. Alright, don't expect really to see that. So now what can we do? So yeah, well effectively the p divided by p cancel each other out. So we can say that's equal to 2 over 8q. Anything else? Divide both sides by 2. So that and that are top and bottom by 2 technically. So we can say that's equal to 1 over 4q. 2 is common to both 2 and 8. Right. What can we do to the one below? 2p squared over 8pq. We can say that cancels and that cancels. Yeah. So it's equal to 2p over 8q. And then we can divide top and bottom by 2 as well. And say that's p over 4q. There will be there may be particular examples in exam questions where I asked for the simplest form. In that case, you're going to lose a mark or two if you don't get all the way to the simplest form. If I don't say that, then an appropriate answer would be okay. So that's important that you know that, and I'll explain that as we do some examples as we go through the module. So I'll be saying, as long as you get to that bit, you already got the right answer. You could simplify to this. All right, but if the question specifically says in its simplest form, then you're going to get marks for getting all the way to the simplest form. All right? How are we doing for time? We've got 10 minutes. You've got a break. 11 o'clock, Omar. Yeah. Normally I'll be half an hour. This week it's actually 3/4 because we started quarter an hour early. Alright? Right, so simplify a cubed b cubed times c times a b cubed times c to the 5. What can we do there? What have I done now? B2, that's this squared. Hold on. You have to keep an eye on me because sometimes my hand go quicker on my brain all the other way round. It's always deliberate though. Just make sure you're awake. So what can we do with that? Yeah, we can combine like terms. So we got a cubed here multiplied by a to the power 4. This is kind of a preamble to laws of indices, which we're going to formalise in a little while. B squared times b cubed. So effectively what we're saying is a b times b times b times b times b, i.e. b to the 5. Yeah? And then c times c to the 5 must be c to the power 6. Right, now, in your bird books, chapter 5, basic algebra, loads more examples. Alright, chapter 6, further algebra skills will be needed next year, if not now. Alright, so given the time, wouldn't hurt at all to look ahead. Okay?
With the bird books, obviously you've got, early ones, are they the same with that?
Yeah, I mean, I'm not sure. That won't be the same chapter in the additional one. And I think if you've already got a bird book now, stick with it. If you want to get the higher one for next year's module, then do so. There's only a couple of topics that aren't in, and I'll use examples from the book anyway. And I'll give you plenty of examples you can try. But if you want to get the higher one, then there are a couple of topics to do in the other module that aren't in this one. The one I've got is edition 7. I'm not sure if there's an 8 now. Not sure. Yeah. Yeah, bird. Yeah. But next year, Daniel, the second maths module, there are a couple of topics that aren't in that book, but they're in higher engineering mathematics. But that same author, but that doesn't go back quite so far. There isn't the level of detail on the basic algebra that is in the first one. So if you can afford both, then up to you. All right. 8th now, is it? Yeah. Minute differences. If you've got a 7 or a 6 or maybe even a 5, I wouldn't bother buying 8. Alright? Yeah, well, I'd go with that if I were you. Yeah. You can get higher engineer mathematics, yeah. Yes. But that one, I warn you about higher, it doesn't go back quite so far, or is not the extensive amount of basic algebra and stuff in higher that's in the lower one. So it's up to you. You should already have the lower one anyway. Don't go and, if you've already got edition 7 from BTEC, didn't you? Oh, okay. In your handouts, I've put in some practice stuff extracted from Bird anyway. Okay. What he does is he puts the answer in brackets afterwards if it's in his books. So that's what you're heading for. Yeah. So that's what he's asking you to do. Remove the brackets and simplify. These expressions in the square brackets afterwards are Mr. Bird's answers. Right? If you've already got 6, 7 or whatever, don't buy another one. In your notes, have you got laws of indices? Does that carry on that far or not? No, okay. Yeah, that'll be this afternoon, then we'll do that.